G'day. If you've been following this video series, you'll realise that I'm in the midst of explaining how to analyse quadratic equations in order to graph their parabolas. Now, one of the steps that we need to follow, or to take, is to analyse a quadratic equation to find where the parabola is likely to touch or cross the x-axis, known on the graph as the x-intercepts, but in factorising the quadratic equation we call them the roots or the zeros. Now, there are three main methods of doing this. One can factorise, one can complete the square, or you can use the quadratic formula. I have just spent, I think I produced about 8 or 10 videos explaining how to factorise quadratic equations of different kinds and using different methods. It's a wonderful skill and you should become quite good at it. But you should also become quite good at the other two methods. Don't just concentrate on one. It's nice to have all three tools in your arsenal, so to speak. And the poor cousin in a lot of school textbooks, certainly ones that I've seen, has been completing the square. Not nearly enough work is done on it. I tend to do a lot of work with the formula and factorising, but I find that students are often quite weak in this in their senior years at school. Completing the square is a very important method, and it's used a lot in other areas of mathematics, in calculus, etc. And it pays to be able to recognise perfect squares or parts of perfect squares and to complete a square. Now, I've produced one video already explaining how to do it with very simple cases. And the simple case is this, that if you have a square that looks like x plus a times itself, you realise, of course, you get x times x is x squared, and an ax, and an ax, and an a squared plus a squared, which is x squared, and ax is 2ax, plus a squared at the end. This pattern, x squared plus 2ax plus a squared, or x squared plus 2xy plus y squared, or whatever version you wish, always has a 2 here because of these two objects in the middle, these two terms. Consequently, if I get a quadratic that has a 1x squared, which we call monic, and that's the sort that I discussed in the last video, because it's a 1x squared. We're going to discuss monic quadratics in this one as well. If we have an even number in front of the x, an even coefficient of x, it's easy to complete the square because it's 2 times something, 2 times a whole number. When we have an odd number, it's a little more complicated. So let's have a look at such an example and see how we would handle one with an odd coefficient. Now it's still monic, so it's still starting x squared, and I'll do a positive one this time. Let's make it 5x, and let's make it plus 2 equals 0. There's our quadratic. Now, it should be quite obvious that this is not factorisable. It won't take you long to determine that. I'm going to talk in later videos about how you can check that for yourself very quickly, but a little bit of trial and error there would convince you. Let's complete the square. We would leave the first two terms alone and just not even try and modify, just get rid of this term completely by subtracting it. But because we're in an equation, we have to subtract it from both sides, so in a way it moves over and takes the opposite sign. Now negative 2 over here. But this has cleared this area for us to complete the square, which is why the process has the name it does. How do we complete the square? Well, if I want to know what this a is, I've got to find half of the 2a in the middle. And half of 5 is 5 on 2. A lot of students like to go straight to using decimals. I find that fractions are actually a nice way to go with these, and I encourage you to practice this way because if you're using it in calculus, you'll have fractions involving trig functions, etc., etc. This is actually a nice way to go. And we've got to add this to both sides of the equation to keep it balanced. Now, fractions may not be your favourite thing, but I hope they will. I hope you'll appreciate them here. This conforms to this pattern. We have x squared. We've got twice 5 on 2 here, and we've got 5 on 2 squared there. So this is x plus 5 on 2 all squared. In other words, that is the completed square. What have we got on this side? Well, somehow we've got to combine these. Well, I'm going to leave the negative 2 here, and I'm going to square this. Squaring 5, it's 25 over 2 squared is 4. There's not much I can do at this point with this side because I want to combine these. Now, this is 2 over 1. That's what 2 is, or negative 2 is negative 2 over 1. I can add these if they have the same denominator. So all I do, I know this is a bit colourful, but all I do is I multiply the top and the bottom of this fraction by 4. And now you can see that they're both over 4. 4, once 4 is 4. So I'm going to put it all over 4. And negative 2 times 4 is negative 8 plus 25, which is 25 minus 8, I think is 17. Now we take the square root of both sides. I'm doing it the way most school textbooks do. It's not ultimately the best method. I'll be explaining that in another video. But the square root of this is that. The square root of this will be plus or minus the square root of 17 over the square root of 4, which is 2. And you can see that by leaving it as fractions, we will end up with the same denominator. And now all I do is I subtract that 5 over 2 from both sides, and I get minus 5 on 2 plus or minus the square root of 17 on 2, which I think I'm just about off the bottom of the board, but I think I can just squeeze this in. All over 2 will be minus 5 plus or minus root 17. So one root would be minus 5 or negative 5 plus root 17 on 2, and the other would be negative 5 minus root 17 on 2. And there we are. That's completing the square with an odd coefficient. We will get fractions. Don't always get surds, by the way. We'll talk about that when we get to the formula, when we talk about the quadratic formula. But we will get fractions if you have an odd number here. So if you want to stop the video here, you may. I'm going to do one more example in case you just want to make sure of it. I'm going to put a negative number and we'll see how that transpires. I'll go through it much more quickly. But if you want to stop here, let me encourage you to leave a comment, click the like button, subscribe, do it whichever you wish, and I thank you very much for watching. If you want to continue, then let's have a look now. Well, here we go. Let's have a look at this one. X squared, let's make it minus 7x minus 4 equals 0. So let's try this one out and see what we get. Now, procedure, leave this alone. As before, move this to the other side where it becomes a positive 4. Now completing the square, which I'll do in red. We need half of the negative 7. I will leave the negative sign in, but it's not absolutely necessary there. And we add that. And that completes our square. So the completing the square is actually a simple thing if you don't have to worry about what that's actually worth. Now, the square is going to be x minus 7 on 2, all squared. You can see our x squared, this squared is here, and twice 7 on 2 is just negative 7. And on this side, let's work this out. Now, we've got 4 plus negative 7 squared is plus 49. 2 squared is 4. And as before, because I want to change 4 to have a denominator of 4 like this one, I'll multiply both top and bottom by 4. By the way, you don't need to write these in. They're a bit like training wheels. I used to have one on my pet horse until I got better at riding. Not entirely true, but still. They're like training wheels. You don't need them later. And here we get 16 plus 49 all over 4, which is 50, 65 on 4. And then we would take the square root of both sides. Now the square root of this side will be x minus 7 on 2. Square root of this plus or minus root 65 on the square root of 4, which is 2, and these should match up. And then I add 7 on 2 to both sides, and I get 7 plus or minus root 65, and they're both over 2. So my roots are going to be 7 plus root 65 on 2, and 7 minus root 65 on 2. Now you can't do it here, but don't forget, if you have a radical or a surd, depending on which country you're in, what you call it, don't forget to simplify it if you possibly can. But of course that's worth about 8. 8 squared is 64, so it's just over 8. So averaging 7 and 8 would be just over 7.5. And be about minus a half. So if we graph this parabola, by the way, it means that one root will be at about minus a half, and the other one, what did I say, about 7.5. Well, on this scale I really haven't done myself any favours, have I? 1, 2, 3, 4, 5. I'm off the side of the board, but if we just imagine, 6, 7, 8, the parabola would come down through those, and negative 4 would be the y-intercept, 1, 2, 3, 4. So we've got quite a steep parabola, and we would worry about the rest of the drawing at other times, but this is how you find the roots or zeros by completing the square. Thank you very much for watching.